Hey folks, tutorial on G67 12.2A4. I like this one because it's a little tough. I'll show you what I'm saying. You roll a pair of dice. What is the probability of rolling a 2 and then rolling a 7? Well, a lot of people think they can do this just by like doing 1 times 6 and 1 times 6, or forgetting that they're talking about a pair of dice, and if you roll one die, there's no way of getting a 7. So how do you answer this? Well, it's a little more complicated than you think. You have to think about all the different possible pairs you could have, the combinations. So if you roll your first die, you could have a 1, a 2, a 3, a 4, a 5, or a 6. On the other one, you could have a 1, a 2, a 3, a 4, a 5, or a 6. So I'm just going to make a little chart here. Okay, well, you could roll a 1 and a 1 and you'd have a 2. You could roll a 1 and a 2 and you'd have a 3. A 1 and a 3 would be a 4, a 5, a 6, and a 7. See how you can kind of, this would be your first, this would be one die, and here's the other. All right, so let's see. This here, you could have a 2 and a 1 would be a 2. A 2 and a 3 would be, a 2 and a 1 would be a 2. A 2 and a 2 would be a 4. A 2 and a 3 would be a 5, 6, 7, 8. You can see there's a pattern here. The 3 and the 1 would be 4. A 3 and a 2 would be 5. A 3 and a 3 would be 6, 8, and 9. And you could just kind of continue this pattern here. This is going to be 5, 6, 7, 8, 9, and you could actually have a 10 with a 4 and a 6, right? So yeah, two-digit numbers are possible. All right, here you could have a 5 and a 1, so this would be 6, 7, 8, 9, 10, and 11. I think you get the hang of this. I'm just going to do this. Okay, so now let me just grab my highlighter here. So what's the probability of rolling a 2 and then rolling a 7? Well, there's only one way that you can roll a 2 here. There's a total of 36 different possible combinations here if you want to count these. It's a 6 by 6 array. So on this first one here, you have a 1 in 36 chance of rolling snake eyes, or 2 1s. Okay, but you'll notice a lot of 7s. So then rolling a 7, you've got 1, 2, 3, 4, 5, 6 7s. So really you have a 6 in 36 chance of getting a 7. Well, you have to multiply these together. We can cross reduce. Divide by 6 here, you have 6. Divide by 6 here, you've got 1. And then you can multiply these. 1 times 1 is 1. 6 times 30 would be 180. 6 times 6 is 36, so this is 216. You have a 1 in 216 chance of rolling a pair of die, and the first time you roll 2 or 2 1s, and the next time rolling something that adds up to be a 7. That's what I'm talking about. They take a little work. Let me just do one other one here. And maybe you won't even do it, but let's just take a look at number 15 here. The letters of the word algebra are placed in a bowl. What is the probability of choosing a letter other than A and then choosing A? Well, the question is, do you put them in the bowl or do you put them back? So let's just think about this. 1, 2, 3, 4, 5, 6, 7 letters are in the bowl. So you've got 2 A's in there. Starts and ends with an A. So what is the probability of choosing a letter other than A? Well, the first time you go in, you have 5 7ths chance of doing it. Now, if you don't, if you put it back in, then you're going to have a different answer than if you don't. The question is it dependent events or independent? So let's figure it out both ways. What's the probability of choosing a letter other than A and then choosing the letter A? So the first time choosing the letter other than A and would be 5/7, and then choosing the letter A would be 2/7. Now, we didn't change the bottom number. This means we're putting the letter back. So we can multiply these out, and we are going to get, we can't cross-reduce at all. So this would be 10/49. This is if they're independent events. Now, dependent is going to be a little bit different, because when we do that, and I'll move it down here. If they were dependent events, it would be 5 out of 7 that first time still, but then there's going to be one less letter in there. So 1, 2, 3, 4, 5, 6, 7. Of course, it'll only be 6, and we have to, and there still could be 2 A's in there. So then we can cross-reduce this and make this into 1/3. It's not cross-reducing, I guess, but 5 times 1 would be 5. 7 times 1 would be 21. So this would be the dependent. And why are the odds better? Well, because you have less letters in there. So the fewer it are, the smaller the probability. So I guess I would figure these out both ways, and I probably will have you working with groups and not doing all of them, because it's a pretty long assignment, but I think it does have something to offer. Thanks for listening.